So in this lesson, we're going to talk about inverse functions and their equations. And we're primarily going to focus on linear functions. But you can find the inverse of a function by following these steps. Okay? What you're going to do is replace f of x or g of x or h of x with y, because again, those are just fancy for y. And then because you're finding the inverse, you're going to switch x and y. Okay? They're going to trade places. Then you're just going to solve for y, and your last step is to replace y back with f to the negative 1 of x or g to the negative 1 of x. That's just our way of saying inverse in math. So let's take a look at how this looks. Okay. So we take a look at number 1. To find the inverse, our first step is to switch x and y. Or sorry, to write f of x as y. Because again, it's fancy for y. So we are going to write it as y equals negative 2x plus 3. Then x and y are going to trade places. They're going to switch. The numbers stay exactly where they're at. Just the variables change. We don't really see equations like that, so what we have to do is solve for y. We are going to get y by itself, just like you were solving for x. So we're going to move this 3 over by subtracting it. So we get x minus 3 is equal to negative 2y. We're going to keep getting y by itself, so we're going to divide by negative 2. And we have to divide everything by negative 2. You can leave it like this. This is totally fine. Or, the more proper way to write it is we have that negative in the bottom here. So you just divide everything by a negative. So this becomes negative x plus 3 divided by 2. Both are correct. Okay, so you can leave your answer as this. And our last step is to make y f to the negative 1 of x. So you could have left it like this. Totally fine. You could have left it like this. Totally fine. Or you could have written it like this. Because when we divide here, x divided by negative 2 is just negative 1/2 x. And then when we divide here, negative 3 divided by negative 2 is just positive 3 over 2. Either one of these solutions is the correct way to write the final answer. So if you just want to write it like this and stop, totally fine. If you want to keep simplifying a little bit further, you can write it one of the other two ways. Okay, so we're going to take a look at 3. Same kind of thing for 3. Change h of x to y. Switch the x and the y. Again, the numbers stay exactly where they're at. You just switch x and y. And then solve for y. So we're going to get y by itself. To do that, we need to get rid of the denominator. Okay? So I'm going to multiply both sides by 2. When I do that, the 2's just cancel. You don't distribute the 2 to the top. They just cancel out. So we're just left with 2 times x is 2x, 7y plus 18. Then we keep solving for y. I'm going to move the 18 over. So I get 2x minus 18 equals 7y. Keep getting y by itself, so I'm going to divide by 7. I'm going to divide everything by 7. 7 can't really go into 2, and 7 can't really go into 18. So again, you can just leave it like this. This is totally fine. Or you can write it as 2 individual fractions. Either way is fine. And then your final step, don't forget, change y to this notation. And that should be an h. So I have an h on the outside there, so it should be h. equals 2x minus 18 over 7. This is our final answer. Again, this notation right here just is telling you that's the inverse of the h function. So we're going to explore a relationship between a function and its inverse using function composition. So what we did last unit. Okay, so in order to do this, we're going to find f of g of x and g of f of x, meaning we're going to take one function and plug it into the other, and then take the first function and plug it into the second function. Okay, we're going to take a look at this with problem 5. See what this looks like with problem 5. And 5, this is kind of that goofy notation. That's why I like to do this. Kind of make it look like the other ones. So yeah, this is what we did last unit. So this is saying take the g function and plug it into the f function. Well, if we look, the g function is 2x minus 6. So I'm going to take whatever function's on the outside, write it exactly as it is. Well, there's an x, put parentheses. So the f is on the outside, so I'm going to use the f function. Then whatever's on the inside, which is 2x minus 6, goes on the inside there. Then we just simplify it down. So I'm going to distribute the 1/2. 1/2 times 2 is x, and 1/2 times negative 6 is negative 3. And then don't forget to bring down the 3. When we combine our like terms, the 3's cancel, and we are just left with x. Now, we are going to do the same thing with b, except flip-flop the functions. Now, g's on the outside, and the f function's on the inside. So the f function is 1/2 x plus 3. So I'm going to write the g function, because again, that's what's on the outside, exactly how it is, but where there's an x, I put parentheses. Whatever's on the inside here is on the inside here. Simplify it down. So I'm going to distribute the 2. 2 times 1/2 x is x. 2 times 3 is 6. Bring down that negative 6. When we combine my like terms, they cancel, and I'm just left with x. So the result of both compositions was x. Oh, wrong one, sorry. So far, it looks like two functions are inverses if and only if f of g of x is equal to g of f of x. Meaning if you take one function and plug it into the other, you should get x as an answer, and then flip-flop it. So if we take the second function and plug it into the first function, we should get the same result as taking the first function and plugging it into the second function. So let's take a look at one more example of this. So we take a look at number 6. We want to show that the following functions are inverses. So we are going to use that notation. We're going to do composition of functions. We're going to see if this is true. Okay? So I'm going to first do f of g of x. And we're going to see if we get the same thing as g of f of x. So when I do f of g of x, the g function is negative x plus 1 divided by 4. So I'm going to take the f function, write it exactly how it is. I'll write it down here. Where there's an x, I put parentheses. I have a negative x plus 1 divided by 4 inside my parentheses. So a negative x plus 1 divided by 4 is going to go inside my parentheses. Here, we're multiplying by a negative 4 and we're dividing by a 4. So the 4's are going to cancel out. You don't distribute the 4 to the top. The 4's just cancel. But this negative is still on the outside. That's still there. But the 4 in the numerator and the 4 in the denominator just cancel. Okay? Well, that negative 1 out in front, or that negative, is representing a negative 1. So to simplify it down, we're just going to keep distributing. So we get x minus 1 plus 1. We're going to combine our like terms, so we get x. Now let's see if we get x for the other one. So now we're going to find g of f of x. Well, the f function is negative 4x plus 1. Okay, so I'm going to write the g function exactly how it is, but where there's an x, I put parentheses. And then whatever's on the inside here, which is negative 4x plus 1, is going to go on the inside here. So negative 4x plus 1 goes on the inside. Again, that negative 1 out in, or that negative right out in front is just a negative 1. So I'm going to distribute that negative 1 in the top. So I get positive 4x minus 1. Rewrite this plus 1 all over 4. Clean up your numerator first. When I go to combine my like terms, the 1's cancel. So I'm just left with 4x over 4. Well, here, the 4's cancel. 4 divided by 4 is 1. So we're just left with x. They equal each other. So yes, these are inverses. Okay, this was true. F of g of x was equal to g of f of x.